Unit 3, Section 2, Sequences. Searching objectives. By the end of this session, the student will be able to 1. Find the terms of a sequence, and 2. Find the nth term of a sequence. Sequence. Sequence is a set of numbers that are arranged either to follow an order or not to follow an order. And these numbers continues indefinitely. The numbers in sequence are often written as A subscript 1, A subscript 2, A subscript 3, A subscript 4, up to infinity. A simple example of this is 5, 10, 15, 20, 25, up to infinity. Then these numbers in this sequence can be obtained by the formula A subscript n is equal to 5n, where our n is 1, 2, 3, 4, 5, 6, up to infinity. These terms are obtained from this general formula for this sequence because when we take n to be 1, then our n subscript 1, which is the first number, and we call it the first term, is equal to 5 multiplying 1, which is 5. And that gives the first number 5. When n takes 2, then meaning our second term or second number, which is A subscript 2, equals 5 multiplying 2, which is 10. That is why the second number is 10. If n takes 3, then our n subscript 3, which we call the third term or the third number, is equal to 5 multiplying 3, which is equal to 15. If n takes 4, then our A subscript 4, which is the fourth term or the fourth number, gives 5 multiplying 4, which is 20. If n takes 5, then our A subscript 5, which is also called the fifth term or the fifth number, is equal to 5 multiplying 5, which is 25. If n takes 6, then our A subscript 6 is equal to 5 multiplying n, which is 6, and that gives 30. That is the sixth number, and it continues like that. Now, another way of obtaining these numbers can be A subscript n is equal to A subscript n minus 1 plus 5. Starting from the first term, A subscript 1, which is 5. Now, what it means is that if n takes 2, then our A subscript 2 is equal to A subscript 1 plus 5. Already we know A subscript 1 is 5. So 5 plus 5 will be 10. That is the second term or the second number. If n takes 3, then our A subscript 3, which is the third number or the third term, becomes A subscript 3 minus 1, which is A subscript 2 plus 5. Already we know A subscript 2 is 10, and 10 plus 5 equals 15. Then we can obtain other terms or other numbers in the same manner. Definition of sequence. A sequence is a function A whose domain is the set of natural numbers. The terms of the sequence are the function values A of 1, A of 2, A of 3, A of n, up to infinity. We usually write A subscript n instead of the function value or function notation A subscript n. So the terms of the sequence are written as A subscript 1, A subscript 2, A subscript 3, A subscript 4, dot dot dot, comma, A subscript n, comma, up to infinity. The number A subscript 1 is called the first term. A subscript 2 is called the second term. And in general, A subscript n is called the nth term. Oh. Finding the nth term of a sequence. Example 2. We want to find the nth term of a sequence whose first several terms are given as A, 1 over 2, 3 over 4, 5 over 6, 7 over 8, up to infinity. B, negative 2, 4, negative 8, 16, negative 32, up to infinity. Now, for us to find the nth term of the first sequence or the sequence in A, then we look at it in terms of numerator and the denominator. So when we consider the numerators of the sequence, we see that the numerators are odd numbers. And we know any even number minus 1 will always give us an odd number. So if that is the case, and we know all even numbers are 2 times n, then when we subtract 1 from 2n, it should give us odd numbers. That is, if we replace n by 1, then we have 2 times 1 minus 1, which is 1. When we replace n by 2, that will be 2 times 2, which is 4 minus 1. When we multiply n by 3, that will be 6 minus 1, which is 5. When you multiply n by 4, that will be 8 minus 1, which is 7. So the numbers, the odd numbers we have as our numerators will be given by 2n minus 1. Now, observing the numbers we have in the denominators, we realize that they are all even numbers. And if they are even numbers, and we know even numbers should be 2 times any number. So if the numbers are assumed to be n, then the terms or the numbers in the denominator should be given by 2n. Hence, the general term or the nth term, A subscript n, is equal to 2n minus 1 all over 2n. Now, when we consider the sequence we have in B, we realize that they are all powers of 2, but the signs changes, meaning we have negative, positive, negative, positive. So the terms in that sequence should be given by A subscript n, which is equal to into braces negative 1 exponent n, then times 2 exponent n. So that when we want to find the first term, then we substitute 1 into this formula. We have A subscript 1, which will be the first term, which equals to negative 1 raised to the power 1, which is negative 1, times 2 raised to the power 1. So that becomes negative 1 times 2, which gives the first term negative 2. When we want to find the second term, we put 2 in place of n. So A subscript 2 equals negative 1 to the power 2 times 2 to the power 2. Now, negative 1 to the power 2 will be positive 1 because the exponent is an even number. So that we have 1 multiplying 2 to the power 2, which is 4. So 1 times 4 is 4. If you want to find the third term, meaning we are putting 3 in place of n. So A subscript 3 equals -1 exponent 3. Since 3 is an odd number, it means -1 exponent 3 gives -1. Then multiplying 2 exponent 3. 2 exponent 3 is 8. So if you multiply 8 by -1, that gives -8. When we are finding the fourth term, then we put 4 in place of n. So a subscript 4 equals -1 exponent 4. -1 exponent 4 is 1, since 4 is an even number. Now 2 exponent 4 becomes 16. So 16 multiplying 1 gives 16 as the fourth term. To find the fifth term, we put or we substitute 5 in place of n, so that our a subscript 5 is equal to -1 exponent 5 multiplying 2 exponent 5. Now -1 exponent 5 gives -1 because the exponent 5 is an odd number, but 2 exponent 5 gives 32. So 32 multiplying -1 gives -32 as our fifth term. And the other terms can be obtained in the same way. Meaning of recursive sequence. Recursively defined sequences. Some sequences do not have simple defining formulas like those we've looked at so far. The nth term of a sequence may depend on some or all the terms preceding it. A sequence defined in this way is what we call recursive sequence. These sequences are defined by a relation connecting consecutive terms. Finding terms of recursive sequence. A sequence is defined recursively by a subscript 1 is equal to 1. That is, the first term is given to be 1. And the relation a subscript n is equal to 3 into braces a subscript n minus 1 plus 2. Now we are to find the first 5 terms of the sequence, but already we are given the first term. So we are to find the second, third, fourth, and the fifth terms. Now, to find the second term, in place of n, we put 2. So a subscript 2 is equal to 3 into brackets a subscript 2 minus 1, which gives a subscript 1, then plus 2. But we know a subscript 1, which is the first term, is given to be 1. So it equals 3 into braces 1 plus 2. And 1 plus 2 is 3. So 3 times 3 is equal to 9. That is our second term. Our third term, we have a subscript 3 is equal to 3 into braces a subscript 3 minus 1, which is 2, the plus 2, which gives 3 into braces 9, since we know the second term to be 9, then plus 2. 9 plus 2 gives 11, and 11 times 3 is 33. To find our fourth term, we put 4 in place of n. So a subscript 4 is equal to 3 into braces a subscript 3 plus 2. Now we know a subscript 3 to be 33, which gives 3 times 33 plus 2. Now 33 plus 2 is 35. When 35 is multiplied by 3, it gives 105. Hence, our fourth term is 105. To find the fifth term, we put 5 in place of n. Hence, we have a subscript 5 is equal to 3 into braces a subscript 5 minus 1, which is a subscript 4, plus 2. But we know a subscript 4 to be 105. So this equals 3 into braces 105 plus 2. And 105 plus 2 is 107. So if 107 is multiplied by 3, it gives 321. So therefore, our first 5 terms of the sequence defined by the relation are 1, 9, 33, 105, 321, ellipsis.